Hello, everyone. Welcome to the next session as everybody joins in. It's going to be very interesting in an industry that is fairly complex, having studied embedded systems and electronics and knowing what it takes to work with semiconductors. I'm really looking forward to the presentation. So we do have four gentlemen that will be presenting what it takes to leverage Node-RED across different facilities in the OT and IT environments. I leave the stage to you with an introduction as well as the session, which is going to be in the semiconductor industry. Thank you so much.
Thank you, Vlad. Okay, so yep, thank you very much, Vlad. I'm going to start out by introducing the team at Intel that has been working pretty heavily with Node-RED for the past 6 months. I believe we've been working. So we all come from a traditional OT controls background. Anton, who's in Oregon, has been in semiconductors for more than 15 years. Same goes for Robbie. Rob's in Ireland. Nico comes initially from food and beverage, but now at Intel, he's within the semiconductor industry as well. He's in Oregon. And then myself, I was initially in power generation, then moved over to Intel, and I'm currently in Costa Rica. So, we wanted to start out by kind of introducing the landscape in which we work. So we make up kind of a larger team of IT and OT engineers at Intel that are tasked with automating initially the facilities. So all of these semiconductor fabs require a lot of material. They require a bunch of things to be online and operate and be able to create and build semiconductors. So initially within the facilities space, we were primarily concerned with power, getting ultra pure water, getting the chemicals and everything ready for the etch tools, as well as making sure the HVAC, all of the filtering, like everything that keeps the clean rooms clean. And then also the back end of this whole process, which is exhaust management, waste abatement, wastewater treatment, all of these things. We're starting to get more into what's known as a subfab space, which is kind of between the facilities and the actual tools. And Anton is going to present a little bit more about that. But yeah, that's kind of, I wanted to kind of start out by stating that that's the space that we work in. So it is very similar to maybe some other people within the energy industries or food and beverage or really industrial controls in general. So with that out of the way, just going to start out by kind of what our landscape and how we approach automation is within our team. So first of all, we need to collect data. We need to collect data from various sensor signals that may be instrumentation devices that are all across the globe. Once we have that data, we need to publish it or we need to transmit it out to either a centralized place or to different clients around the globe. So once we publish this, we then transform it, and this transformation is going to then create like what most of us know as SCADA tags, really just data values that we're able to analyze within our historian. So we use a time series historian to be, and that's kind of the central part of our whole environment, which stores the data and makes it available to downstream analytics and as well as downstream operations. So with the analytics engine that we have, and we have a pretty robust analytics program that involves predictive monitoring, modeling of different processes, digital twins, simulations. This gathers the data that we're pushing to it from the sensors and then outputs either an alert or possibly an action that needs to be taken. So these alerts are then pushed to operators, and then finally we may want to dispatch, or we may want to do something actually like actionable within the real world with the data. So that's the last step we're at right now, which is this dispatching. As you can see in this diagram, we are starting to use robotics as well. So we do have Boston Dynamics spot robots doing rounds and readings around the plants. And we also have the option to dispatch them. So in this case, this example is just kind of an illustrative example of a pump. We have vibration monitoring on it. We have an outlet pressure monitor. It goes through this stack, eventually goes through our analytics engine, and it outputs, hey, there's an issue. There's something abnormal going on with this. The idea here is that we would dispatch, in this case, the robot to go and get a visual confirmation, possibly take a thermal reading and find out if maybe there's a hot spot there, maybe something needs to be done, replaced or taken offline. This also complements our kind of technicians that are also going out to address these issues. And this whole kind of loop is going to continuously work so that we can send that data out and perform actions on in the plant.
Okay, I'll talk a little bit of this one. So after Alex kind of went over what we are trying to do, I'm going to talk a little bit of as to how did we land it in Node-RED, right? Like what were the challenges of our previous approach and why it wasn't optimal. The first thing is we were channeled to use IT resources. Again, as Alex mentioned, we come from the operational technology background, so PLC, process engineering, and things like that. So we were not really able to develop the solutions end to end ourselves. We had to work with resources from other groups and fight for those resources with the rest of the company. The data formats that we were getting from the different solution or the different use cases were all over the place. Some of them existed and we were plugging into them. Some of them were brand new and we had to develop them. But again, we had to use those IT resources, so it kept slowing us down. One of those, once those solutions were developed, they were not really easy to just plug and play to develop new ones. So again, it was almost like every single time we had to go back down, which really slowed us down on really being able to achieve the results from these use cases and the full automation loop that we are trying to build. On top of that, as we were building this solution, we were the only people using it. So we were finding our own bottlenecks around, again, maybe it was not able to handle all the data. Maybe there was bugs that we were not aware of, which in combination with the fact that multiple teams were supporting it, made the support strategy very complex. And really our customers were not receiving the service that they wanted it. So that's kind of where we found Node-RED. It allowed us to streamline or I guess own all these aspects of the solution ourselves, and it also gave us a solution that already was robusted and tested by a lot of other people around the world, right? So yes, there is things that we are developing in-house for it, but also we are leveraging a lot of community nodes that are being developed by others and tested by other industries. So yeah, that's a little bit of how we got to Node-RED. So you can go to the next.
Yeah, so as Nico was mentioning, we had these challenges, and this is kind of an illustration of where we were before Node-RED. So we were already bringing in IoT data, we were already bringing in robotics data, and we were pushing everything through mostly MQTT. And so we had a central MQTT broker, and we had these globally distributed gateways, and we would have like different scripts at each of these gateways that were aggregating the data, collecting it and sending it, publishing it over MQTT. And then on the receiving side, we had a kind of this intermediate platform that would, and basically an ETL, extract, transform, load of data, that was bringing in the data, each data source, and we kind of had a separate data loader for each use case. So every single time a new use case would come through, we had this development team that would create a new template, and they would create the client, MQTT client, and then the transformation in the middle, and then the publishing portion of it as well. And then that's how that data would get over to the historian. So at the time it worked because we didn't have as many use cases, and we didn't have to scale up that quickly. But once the scaling became kind of the factor that we needed to optimize, we needed something else. So that's when Node-RED kind of came along, and Nico was actually the person who kind of introduced us all to this, as I remember. We started to gather the same source of data, so the same globally distributed gateways. The data is all kind of different formats. This would then go through that central MQTT broker, but now instead of having all of these different data loaders, we had this one single data loader, which was Node-RED, where we kind of had the same front end and back end handling the data. So subscribing to it, the MQTT topics, and then publishing out to MQTT topic for our historian to pick up the data. The big difference here was that these transform blocks were no longer separated, but instead we were able to kind of scale everything within Node-RED. And these transform blocks are really just function nodes, split nodes, joins, templates, and then we have some more kind of complex use cases that we'll see in a few more slides. But it allowed us to really start to scale up at a different level than before, because we only had to worry about this one instance and really focus our development resources on making sure this instance and this server in this case was as highly available as possible, so that we could provide the OT side with, hey, if you want to bring in this data, use this application that's very easy to use, Node-RED, and just code in what you need to transform the data into that single format. So with that being said, and that's where we were at phase 2, what we're trying to get to is pushing Node-RED over to the edge. So we want to be able to transform the data and actually have it all in a standardized format that we have control over from the get-go. So again, we still have these globally distributed gateways. Sensor data might be coming in different for each of the different gateways, but eventually what we're doing now is we're publishing to the MQTT broker in the same standard format. And what that does for us is it pushes away kind of the centralization of this from the historian over to the MQTT infrastructure. And what that provides us is we now have the ability to and we don't have this yet, but this is what we want to get to, where we have the ability to plug in our analytics engines directly to the broker and not have the historian continue to be that middle piece, but instead be able to bring our analytics even closer to the edge as well. And then further on, if we want to do command and control, or if we want to do the dispatching that I was discussing in the first slide, it's also going to be closer to the edge and to the devices that it actually needs to send these messages to. So with that, we've kind of solved this issue of having everything depend on our historian and instead pushing this to MQTT, which makes for a better kind of single or central repository for the data.
So at Intel, every second of tool uptime matters. A single minute of downtime can cost thousands of dollars of lost production. So behind the scenes, thousands of subfab devices such as vacuum pumps, abatement systems, chillers, chemical deliveries keep our manufacturing tools running. If these systems fail, production stops. That's why monitoring and optimizing subfab equipment is critical for us. Subfab equipment sit below the fab floor and connect directly to the process tools that make the wafers. Think of it as an engine room in a ship. It's essential, but often invisible. So across our Intel global factories, we manage thousands of these racks with components. Our goals are clear. We want to detect, prevent failures so we can minimize downtime, move from prescriptive to more predictive maintenance, and also reduce energy consumption through smart modes like eco mode when our tools are not running. But here's the challenge. Data from these devices is typically locked in vendor-specific monitoring systems. Each OEM uses their preferred protocol. Some are proprietary, some are legacy, such as like ASCII over serial, and others could be Modbus, OPC, and more. These solutions do not talk to each other. So we have data that's siloed, slow to extract, and often is summarized instead of real time. So this is where Node-RED comes in, acting as our data loader, as you can see in the middle, and as Alex described previously, it serves as our universal translator. It bridges the multiple protocols and streams real-time data into our centralized analytics platform, which you can see in the top right corner. Its flexibility and low-cost approach allows us to integrate diverse equipment without having to rewrite everything from scratch, which is key for us because we need ease of deployment at scale. Today, we do have a working pipeline, which is the one that is shown across the top, where we install IoT gateways on the racks of the Subfab equipment, and we can extract the data and publish that MQTT payload. We are working on the other pipelines, basically enabling REST API requests from existing network rings and being able to parse JSON payloads with Node-RED. And then finally, we also want to get to expand to TCP protocols like the SemiSexGEM, which is a semiconductor industry standard. So by unlocking real-time data, we're paving the way to predictive insights, energy optimization, and smarter manufacturing across Intel's global fabs. Node-RED isn't just a tool for us, it's enabling our journey towards a more resilient and efficient factory. Thank you.
Okay, I'll touch on some IoT use cases. So there can be many. This example is talking about AI and AI models. So this example using the floor leak detection. So we have many pipes, many pumps, all water, and we have to look out for these types of leaks. So our AI team, our team who build these models for us, tend to build them in Python and O and X. But we can still utilize those through Node-RED. We use Node-RED as the orchestrator of the tasks being done at the edge. So Node-RED is what use our interfaces with the camera and is used to pull images in. They save those images, and that's capturing that image every couple of seconds, right? So it pulls it in, stores the image, then pushes the exec node to actually run the Python, which in turn runs the ONNX model, pointing it to that saved image. The analysis is done. Is there a leak or is there not a leak? And returns the values, both the image and the result are returned back to Node-RED. We do save those images, those results images, but we publish on, if there is no leak, we just publish that there's no leak. But if there is a leak, we send a annotated image across with the result showing, as the image on this slide shows, hey, we've detected leaks and here's what we think they are. So that gives context then to the technician receiving those alerts and alarms that they can check before going out into the field how severe or not severe this leak is, and how much urgency they need to have gone out into the field. So that's that one. Yep, cool.
Okay. So now another use case that we are looking into is how to automate business processes. At Intel, as Vladimir was mentioning, it's quite a complex process to make semiconductors. So there's a lot of different groups within the company, and each of those groups owns different parts. A lot of times that information is stored in silo databases. Getting the information out of there, a lot of times is a resource intensive and repetitive process. So in the example below and how we are starting to use Node-RED, and this is one of the use cases that we are today developing, is basically to automate the process of implementation of changes to alarm set points on process stacks of statistical analysis. Basically, there's a governing body that approves those alarm set point changes. And today, that data is kind of siloing in there. The way that the changes happen is via an email to the site engineers, and then those site engineers have to implement it, which is, again, prone to error because of having multiple humans making those changes. It's slow because it's depending on the bandwidth of the engineer, but also there's no closed loop feedback of the change has been implemented. Where we're moving to is we want to allow an automated implementation that when that governing body makes a change to those set points, Node-RED basically captures it via the API of the database and pushes it to the different sites accordingly. In the sites, it gets implemented into SCADA via OPC, and there's a confirmation that goes back to the database itself. At the site, those Node-RED instances, they have some safety, or I guess the application is thought out with safety in mind. So it captures errors, it captures, makes sure that the change has happened. And if something doesn't go according to plan, it immediately triggers an alarm to warn a human that something has gone wrong. But this is one of the use cases on how we are also trying to automate business processes that are intensive for humans today. So go to the next. Finally, I want to talk a little bit about the considerations. Obviously, Node-RED is a powerful tool. It's easy to use, but there is a lot of considerations to keep in mind when scaling in an enterprise. One is, how do we make sure it has an enterprise-grade observability? We need to integrate the health monitoring and performance monitoring of these applications with the existing ones, right? Our team already owns a lot of applications. We need to make sure we integrate it with the mechanisms that exist today and that are in place today. Version control becomes a challenge as well. As we have more and more of these, we need to make sure that we have visibility of what are the versions of the nodes that we have, what are any potential vulnerabilities that we have, and kind of keep our information security peers happy. Management in our gap networks is a challenge because we don't really allow inbound connections. So we need to figure out how to automate keeping up with all these Node-RED instances because again, as we grow, there's going to be way too many for our small team to keep up with. And then finally, cybersecurity around the supply chain attacks has become kind of top of the list with our info security team. We are exploring using something like an on-prem NPM manager to minimize that and keep track of what are the packages that we are allowed to use, and also make sure that if an issue happens, we have a quick way to identify where it's been used and how to mitigate it. So that's basically it for the presentation. So I guess if there's any questions.
Gentlemen, thank you so much. Really appreciate it. There's a couple of questions. I saw that you've answered a few of them, but do want to re-bring up a couple of others. So are you able to share a little bit more around the architecture and basically the hardware that you're using? I'm assuming that you have server rooms at every site, but are you also deploying on like IPC solutions or maybe controllers like Opto22s or PLC Next from Phoenix Contact? So I guess where does Node-RED actually live hardware-wise?
So for the edge, hardware is on, we're using industrial gateways, running just Linux boxes that are Wi-Fi connectivity. So we're not currently heading out into those Opto22s or anything at the moment. I don't know if there's future plans for that, but right now in terms of the IoT integration, and probably as well for you, Anton, at the Subfab integration where you're using those gateways, it's the same type of gateway. Mm-hmm. So we have a selection of approved devices. Being such a large company, we have security concerns and considerations, and the equipment that we put out in the field has to go through approval loops and be vetted before it goes out there. So we have a selection of gateways that we use, and that's about it. We have different connectivity modes as well, LoRaWAN, Wi-Fi, 5G, or wired. And I always forget wired. But that's about it for the edge. If someone else wants to speak to servers.
I can take it. For the servers, we basically run Windows servers, and we basically deploy to them. Those servers are hosted in data centers, yeah, we basically that's kind of how we deploy it today.
Gotcha. Second question: are you using this for mostly analytics type of applications as you've described, or are you pushing any sort of decisions or data or parameters back to the control systems?
So I guess the last use case is we're starting to get into changing set points and a SCADA platform. We are in development of that. I mean, we have a POC working already, But yeah, we are basically making changes where we have those set points already hosted somewhere, and we're pushing them to our SCADA systems via OPC. Obviously, that push is not just a blind push. There's some checks and balances in the middle. There is some configuration of how big of changes do you allow, what happens if an error occurs, and as I was mentioning, there is alarming in place that if an error is detected or something doesn't go according to plan, a human immediately gets warned of that happening.
Makes sense. What are your thoughts on digital twin? So are you able to utilize some of the data that you're collecting for, projects where if you have a change that needs to be made within the business, you can pretty much forecast what kind of an impact it's going to have on a live system? Is there something like that in place or in the works? I would assume so, but curious on your thoughts.
So the IoT data that
go ahead, Rob.
Sorry, Alex. Yeah. The IoT data that we're pulling in is augmenting a data set that we already have on the OT side. So we have a lot of data from that side that can help build a digital twin, but we also need to pull in those extra parameters just to, fill the picture that bit more. And those models are, yes, going to be used for that predictive piece as well, so that we can have that digital twin and understand what a future failure mode might look like and when it's coming, if best we can, right?
Gotcha. There was a question around replay nodes. So someone in the comments mentioned that they seem like an interesting answer to being able to replay and analyze data during a specific maybe event or failure. Are you utilizing some of the replay nodes currently?
I don't see a huge need for that. Maybe I'm missing something, but we're recording all of our data into our historian, so we have it there to replay at any stage we want. So at node red level, no, not using it unless any of you guys are using any.
No, I know we use that functionality, but as Rob was saying, kind of as downstream from our historian, where historian has all the data, we have a separate app that we can do the replay functionality. But yeah, I mean, definitely something to look into for us. I think I just probably need to see, storage wise, if it's just ending up overcomplicating things, trying to get data back into Node-RED, historical data. But yeah, that's something we're gonna look into for sure.
Gotcha. Last question before we go to the next session is, are you able to comment on how you're normalizing the data, right? So you obviously mentioned multiple protocols coming from different vendors that you need to parse into JSON at the edge. Are you using any standards or have you created your own standard on how to basically pull a lot of that data into historians and other solutions?
Yeah, so the historian will only accept certain formats, and we have amongst ourselves agreed. So I think I answered it by text to one of the questions, but what we're dealing with is this legacy of JSON formatted and not very well JSON formatted payloads coming, and we've also handled those. So we've kind of built from that starting point and not from effectively greenfield. Given the choice, we would have gone with an industrial standard, sure, but that's not what we were given, the hand we were dealt. So yeah, we're getting almost random, as the way I'll describe it, JSON formats with topics that aren't overly useful. They're a bit generic. So at the data bridge, we are massaging those payloads, is how I'll say it, reformatting them so that the data is useful, that we can put it into our historian. And then we're also basically recreating a new topic so that downstream from that point, it's a UNS structure to it that we can identify where this came from, this payload.
Yeah, I would say it's super interesting, and I would be very curious to see where you're at, in a year or a couple of years, because ultimately I think this is the kind of scale that is very unique, and I'm sure you will encounter interesting challenges when it comes to data. But that's a whole other, long conversation. So really appreciate the talk. Thank you so much. I'm sure there's going to be more questions that will probably come your way through LinkedIn or by email. Thank you so much, gentlemen. Appreciate it. Thank you, everyone. And I'll see you
Thank you for the
in the
time.
next session.
Thank you.
Thank you.